Hi guys, welcome to this page of the notes. What we're going to do now is we're going to use the ratios for the special right triangles we just looked at on the previous page to help us find the unknown lengths for some of the sides, right? Now, a couple of quick things. First, really nice, on the SAT and the ACT, they will ask you some trigonometry questions, and for the most part, those trigonometry questions can be answered using these two special right triangles. In fact, they're going to give you on both the SAT and the ACT, in the front of the math section, there'll be a formula sheet. And sure enough, both of these triangles will be given to you on that formula sheet, and the triangles will include the ratio of the sides. All right, now that's the SAT and ACT. Your teacher may ask you to memorize these. I will not, so if you're taking this class with me, I also will give you these on a formula sheet for a test. So please do not think that you need to memorize these ratios. It's good that you know where they come from, how we find them by taking a square, dividing it in half, taking an equilateral triangle and dividing it in half. Simply use the Pythagorean theorem. Certainly something I would expect you to be able to do, but since the SAT and ACT, if College Board doesn't require you to memorize them, then why should I? So, using those special right triangles, which you will be given, here we go, let's solve some problems. The first one I've got is 45, 45, 90. So the 45, 45, 90 triangle, let's go ahead and write in those ratios. Now, this one is actually, I think this is the easy one. Remember, the length of the legs has to be the same. This is the one that comes from drawing a square. And the sides of all four sides of a square are the same. So it would simply be x and x. Then again, if you don't remember what the length of the hypotenuse was, you could use the Pythagorean theorem to find it. Or, again, if you're taking the SAT or ACT, it'll be right on the formula sheet, but the length of the hypotenuse was x times the square root of 2. Now, here's the way that these are going to work. Please notice, in the diagram, I gave you the length of the hypotenuse. It's 10. So that means that the length of the hypotenuse, which is 10, has to be equal to x times the square root of 2. Solve for x. Well, let's solve for x. Okay, here we go. 10 equals x times the square root of 2. How do you get the x by itself? Yeah, divide both sides by the square root of 2. So I'll divide by the square root of 2, divide by the square root of 2, and like is normally the case, 10 divided by, sorry, actually here, let me write it this way. X equals 10 divided by the square root of 2. As is normally the case, right? A little bit of geometry, the 45, 45, 90 degree right, or 90 degree right triangle, that's the geometry, turns into an algebra problem. After we apply the geometry, what is the ratio for the lengths of all the sides? That's the geometry. We wind up setting an algebra problem. And actually, in fact, this does go back to Algebra 1. What I've wound up with here is I've wound up with a number that has a radical, a square root, in the denominator. Hopefully you'll remember from Algebra 1 that we don't like radicals in the denominator. It is not okay to leave that square root in the denominator. You can't hide radicals in your basement without proper permitting, and you don't have the permitting. So we got to get that radical out of the basement. We got to get it out of the denominator. Hopefully you'll remember from Algebra 1, the way that we do that is known as rationalizing the denominator. And it's really simple process. All you're going to do is multiply top and bottom, right? Because algebra says whatever you do to one, you have to do to both. So multiply top and bottom by whatever the denominator is, square root of 2. So I'll multiply the top by the square root of 2. Multiply the bottom by the square root of 2. And then a beautiful thing happens. The square root of 2 times the square root of 2. The square roots cancel each other out. And you're left with just a 2. In the top, you would have 10 times the square root of 2. And simplify. 10 divided by 2 is 5. 5. square roots of 2. Please remember what we just found. We just found the value of x. X is equal to 5 square roots of 2. So here we go. I ask you to find the length of AC. AC is equal to x. That's 5 square roots of 2. I ask you to find the length of CB. There's CB. CB is equal to x, and x is 5 square roots of 2. Perfect. So the geometry, know the ratio for the lengths of the sides of the 45, 45, 90 degree triangle. And you don't even have to memorize them. I'll give them to you. So x square roots of 2. From there, after you apply that geometry, then it just becomes an algebra problem where we solve for x. Yes, maybe you'll need to rationalize a denominator or something like that. Okay, fine, no big deal. And we get the value of x. Let's try another one. Let me erase this before I slide down just to make sure that I have lots of space and I'm not running into anything here. Let's get rid of that. And we've got right here, where is he? There he is. Okay, so now we're going to do a 30, 30, 60, 90 right triangle. Okay, no problem. What is the ratio for the lengths of the sides of this right triangle? I agree, this one was a little trickier. Hopefully though, what you'll remember, or just go back and look at the diagram, right? The distance between the 90 degree angle and the 60 degree angle was, the ratio for the length of that side was x. The ratio for the length of the hypotenuse was 2x. Right, and remember, that's because this guy comes from an equilateral triangle. Well, all 3 sides of an equilateral triangle, in fact, again, I'm freehanding this, so it's not going to be perfect, but, right, if that's my equilateral triangle, all 3 sides have the exact same length, 2x, 2x, 2x. What happens when I divide this side in half? Well, 2x becomes x and x, so 2x, x. Do you remember the length then of the length of the side DF? Again, if you forgot, you could either use Pythagorean theorem to find it. You know these two, you can find this one, or just go back and look at the diagram. It was x square root of 3. Well, that's the geometry, right? The geometry is, do you know the ratio of the 3 sides of the 30, 60, 90 right triangle? Once you apply that geometry, look, we got ourselves another algebra problem. X is equal to 5 square roots of 3. So here we go. In order to find, let's see, let's do, you know what, let's do DE first. DE is equal to 2x. Right, there's DE, D is 2x. X is 5 square roots of 3. So plug that in. 2 multiplied by 5 square roots of 3. That's not bad. 2 times 5 is 10. You get 10 square roots of 3. So there's my answer for DE. Now let's go ahead and do DF. There's DF. DF is equal to x square roots of 3. But I already know what x is. X is 5 square roots of 3. So 5 square root of 3 times square root of 3, right? Look, this square root of 3 is this guy, right? Those square roots of 3. Where did this guy come from? Well, that was the value of x. So 5 square roots of 3, that's x. And then the square root of 3 that was already there. Well, we saw this before. What happens when you multiply square root of 3 times the square root of 3? If you forget, go ahead and throw it into your calculator. Your calculator will tell you that that's just 3. So you wind up with 5 times 3, which is 15. So I wind up with the length of side DF simply being 15. So 15 and 10 square roots of 3. Hey, let's keep going. I got a couple more for you here. These are getting a little easier. Once again, I have a 45, 45, 90 right triangle. So what do I know about the ratio of the sides? Well, at this point, hopefully you're getting pretty good at it. That is x. That is also x. And this is x square root of 2. All right, now that we know that, here we go. What is the length of QR? Well, QR is x, and x is 2 square roots of 6. So QR, 2 square roots of 6. That couldn't be any easier. You don't even have to do any algebra. PQ. PQ is going to be x square root of 2. What is x? Well, x is 2 square roots of 6. So I'm going to plug a 2 square root of 6 in there. I wind up with 2 square roots of 6 multiplied by the square root of 2 that was already there. Go ahead and multiply these guys together. 6 times 2 would be 12. So I wind up with 2 square roots of 12, and yes, just like we've been doing in the last couple of chapters, actually, over the last couple of chapters, we've been dealing with radicals more and more and more. We've been seeing them show up more and more, and we've had to simplify them, right? Simplify them. 12 is not a perfect square. It's not. But I can break 12 up into something that is a perfect square, right? So 2 square roots of 12 is the same as 2 square roots of 4 times 3. Why? Well, 4 times 3 is 12. Why would I break it up into 4 times 3? Because 4 is a perfect square. So I get 2 times 2, right? Because the square root of 4 is 2. And then I still have the square root of 3 left over. I can't do anything with that. 3 is not a perfect square, and I can't break 3 up into something that is a perfect square. Right? So there's nothing else I can do to that. 2 times 2 is 4, and so we wind up with 4 square roots of 3. Just a quick reminder, guys, this answer is not wrong. These two are we're writing equal signs here. Equals, 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 right? These are all equivalent statements. So this is not the wrong answer. It's just not simplified. And in algebra, which we're doing a lot of algebra here in geometry, in algebra, you have to write your answers in simplest form. And that is in simplest form. All right, I got one more here. If it'll slide up for me. There we go. Again, you probably saw it coming. 30, 60, 90 right triangle. Go ahead and drop what we know to be the ratio for the lengths of the sides. Well, again, this is the hypotenuse, and in the 30, 60, 90 triangle, that is 2x. That's 2x. The length of this side between the 90 and the 60 degree angle, between the 90 and the 60 degree angle, would just be x, right? Essentially, we've taken this side of the equilateral triangle and cut it in half. Well, if the side of the equilateral triangle is 2x, you cut it in half, you're left with just x. Again, though, look back. It's on the previous page. And then this guy, x square roots of 3. Oh, sorry, that got ugly. X square roots of 3. There we go. Okay, so now here's what I need to do. I need to find the value of x, and we have ourselves a nice little algebra problem. So 4 square roots of 3 is equal to 2x. How do I get the x by itself? Yeah, sure. Divide both sides by 2. So 4 square roots of 3 divided by 2. Simplify. 4 divided by 2 is 2 square roots of 3. So what's the value of x? 2 square roots of 3. Here we go. Find jk. Well, jk is equal to x. So jk is equal to 2 square roots of 3. No problem. LJ. LJ is going to be x square roots of 3, so here we go. LJ would be equal to, LJ is x square root of 3, right? That's the length of LJ, x square root of 3, but what is the value of x? Well, x is 2 times the square root of 3, so I'm going to plug that in for x. And I wind up with 2 square roots of 3 times the square root of 3 that was already there. And once again, square root of 3 times the square root of 3 is just going to be a 3. And 2 times 3 is 6. And so we wind up with a 6 there. All right, guys, so here's the way that this is going to work. 2 special right triangles, 45, 45, 90, and the 30, 60, 90. You need to know, right, the ratio, well, not you need to know, I'll give them to you, but you need to know how to label the triangle with the ratio of those 3 sides, and then more than likely what's going to show up is an algebra problem. You'll need to solve for the value of x, which then will allow you to find the length of whatever sides I didn't give you. All right, what we're going to do on the next page of the notes is once again take a look at some problems dealing with these 2 special right triangles, I'll meet you there.